Hey guys, today we're going to look at functions with domain and range and identification. The notes that you should have say 1.1 functions guided notes, and I've already filled in a couple of things for you if you'd like to listen and then pause your video to fill those in. Set builder notation is going to have braces with a line and is read the set of values x such that x is greater than 0. Interval notation is going to use parentheses and brackets. Bounded when both endpoints are real numbers, also called finite intervals from 1 to 10. Unbounded, neither endpoint is a real number from negative infinity to infinity. If the value is included, you will use brackets instead of parentheses. And we're going to see examples of that here in examples 1, 2, and 3. Describe the set of numbers using set builder notation. So we're going to use our brace and our x such that the numbers start with 8 and they just keep on going forever. So that would be x greater than or equal to 8. And we're going to be using set builder notation for this and interval notation for the next set. So x is less than 7. So this is x such that x is less than 7. If it's already written as an inequality, the inequality just subs into set builder notation. And all multiples of 3 is x such that 3x is in your set builder notation. All right, using interval notation, you see you have a less than here and a less than or equal to here. So you have parentheses for the less than, your number, comma, your other number, and a bracket. So when it's included or equal to, you make sure you use a bracket. If it's infinity or negative infinity, it always uses parentheses. So all values x less than 11 is negative infinity to 11, both parentheses. X is less than or equal to negative 16 or x is greater than 5, negative infinity to negative 16 with a bracket, and then 5 to infinity in parentheses. If you guys want to take a second and pause your video, you have some information here at the top to write down. The definition of a relation is a set of ordered pairs. Relations can be represented 4 different ways: on a graph, a table, a mapping, and an ordered pairs list, which is a relation. A function is a special type of relation. A function f from set A to set B is a relation that assigns to each element x in a set A exactly one element y in set B. So an example of function, notice the domain doesn't repeat. In this case, the range doesn't either. So this would be a set by domain and by range. We can look at a graph. A line is an example of a function. A vertical line is not, but all other lines are. And a mapping uses two ovals, one labeled X and one labeled Y. And we just have some numbers here, and we will draw some lines. That would be the ordered point 6, 2, 8, 3, and 7, 1. Your domain doesn't repeat. And your table, 1, 4, 2, 5, 3, 6. And then as you see the example that was given here, this would be your ordered pairs list. This would be 1, 6, 2, 7, 3, 8, and 4, 9. The vertical line test is used to determine whether or not you have a point when you have a graph. It looks something like that. If you were to draw a vertical line, it would touch 3 times. This is not a function. If you can draw a graph and it only touches 1 time, then it is a function. That's your vertical line test. So we're going to determine whether or not each relation y is a function of x in terms of the relation. So the input value x is a student's ID number. The output value y is that student's score on a physics exam. Those are probably not going to repeat. Think about your student ID and think about the large number that it is. Chances are good you're not going to make that on a physics exam. So these will be functions And they'll be functions because there's no way that they're going to repeat to each other. All right, B is a graph. Vertical line test. Yes, that is a function. Y squared minus 2x equals 5. Need to set equal to y first. So y squared equals 2x plus 5. Y equals plus or minus square root of 2x plus 5. If you were to graph that on your calculator, square root 2x plus 5 and negative square root of 2x plus 5. I'm going to zoom 6 and get it back to a normal screen, even though you should be able to tell it from here. If you were to draw a vertical line test, you would clearly see that it would touch 2 times. So this is not going to be a function here. Function notation. This is f of x. So an equation would say y equals, a related function would say f of x equals. And if g of x equals x squared plus 8x minus 24, find each function value. So g of x is just g of x. G of negative 4x is negative 4x squared plus 8 times negative 4x minus 24. That's 16x squared minus 32x minus 24. And g of 5c minus 4 is 5c plus 4 squared plus 8 times 5c plus 4 minus 24. So you're going to FOIL this out. 5c plus 4 times 5c plus 4. So that's 25c squared plus 40c plus 16. And then you're going to distribute here and get 40c plus 32 and then minus 24. And I just line that up with all like terms. So 25c squared plus 80c plus 24. As always, if you have questions, make sure to mark them with a sticky note. Now we're going to talk about domain and range. So we have a chart. We're going to fill in a chart here. Negative 2, 2, negative 1, negative 1, 0, 0, 1, 5, 2, 14. This is our table. So our independent values are our x's, negative 2, negative 1, 0, 1, and 2. And our dependent are our y's, 2, negative 1, 0, 5, and 14. That is for not repeating values. So we're going to graph the function. So y equals clear 2x squared plus 3x. And we're going to go to our table. And I'm just going to pick a value. Let's do 565. Because I'm looking for f of 5. So f of 5 is 65. Your input is your x. Your output is your y. So when you put in the 5, the 65 is your result. Taking a look at your graph here, we've got this point, and we've got this point that's on our graph. So we're going to fill in some information from here to here. It looks like we are at negative 1. Then we go up to 1.5, but it's open, so it doesn't include 1.5. And then our range is from here to here, includes negative 2. And then our range is going to be 2. And then we're going to fill in our domain, which is going to be our x values from negative 2 to positive 2. And our range is our y values from -1 to 1.5. And we're going to do the same thing on the other one. Our domain is from our x value to our x value. Notice that it's going to keep on going forever and ever. So that domain is going to be all real numbers, -infinity to infinity. And our range is going to be -2, and it's not going to stop, so it will be infinity. So domain and range. Remember, your domain pertains to x and your range pertains to y. Now we're going to look at identifying functions. Function is a relation where each input produces exactly one output. Input values are our domain, and output values are our range. Inputs are our independent values. Output are our dependent values because they depend upon what you put into it. All right, so order pairs. If an x value repeats with a different y value, then the relation is not a function. This one, 1, 2, 3, 4, 5, doesn't repeat, is a function. 1, 1, 2, 2, 7. So the ones repeat and the twos repeat. So that's not a function. Sometimes it's sometimes easier to see if you list the domain and range for each set. So we just did that. 1, 2, 3, 4, 7. That one was fine. This one had repeating ones and twos. Then taking a look at your table, 4, 7, 8, 12, good. 3, 3, 5, 10, not good. And then the vertical line test. If you draw a line here, your vertical line will touch 1 time. If you draw your vertical line here, it will touch 2 times. And if you draw your vertical line here, it will touch 1 time. So is a function, is not a function, is a function. This concludes our section on identifying as well as domain and range. If you guys have any questions, let me know, and I'll talk to you soon.